Lesson 6-4. Our learning target today is I can solve a system of equations by elimination. Our essential question is how do you solve a system of equations by elimination? So our focus for our EQ today is how you use the method elimination. So we've been working with elimination for quite a few days now. And we learned how to create opposites in a system when we're not given opposites. So we're going to continue working with that. So if you are able to create your own opposites to solve a system, any system can be solved by elimination. So the first thing we do is we look at our coefficients to see if we have opposites right from the start. 6 and 3 are not opposites. -2 and -7 also are not opposites. So what we can do, we don't have to, but what we can do is use the least common multiple. So the least common multiple for 6 and 3 would be 6. The least common multiple for 2 and 7 is 14. So we can choose to either turn our x's into 6 and -6 or our y's into 14 and -14. Creating opposites, we don't have to use least common multiples. As long as we use multiplication to create the opposites, we will be fine. We will be fine. So I am going to choose to cancel out the x's. So I'm looking for 6 and -6 to be my coefficients. I already have +6. So my second equation, if I multiply by -2, will turn the coefficient into a -6. Remember, you need to cancel out one of the variables, either x or y. You need to cancel one of them out. That's what elimination means. You're eliminating one of your variables. Now, make sure that you distribute your multiplication times everything in the equation. So -2 times 3 is -6x. -2 times -7 is +14y. And -2 times -19 is +38. Now my system is ready to solve. 6 and -6 eliminate each other. If I add the remainder, -2 plus 14 is 12. 10 plus 38 is 48. 12y equals 48. If I divide both sides by 12, y is equal to 4. So the y coordinate is 4. I still need the x coordinate for my point of intersection. Make sure you find both variables. I can go back to any of the equations. I'm choosing the one on the top. Y is 4, so my y gets replaced with 4. 6x minus 2 times 4 is equal to 10. 2 times 4 is 8. Now I have 2 steps left because I'm trying to figure out what x is. I need to add the 8 first, which gets me to 18, and then divide by the 6. 18 divided by 6 is 3. So x equals 3. So these two lines intersect and they have one solution, 3, 4. Second example. This one's a little bit different than the first one. The LCM of 4 and 3 is 12. The LCM of 2 and 3 is 6. So what's different on this one is we are going to have to change both equations. So changing both equations, whether you want to change the x's or the y's, it's up to you. So the first equation, I'm going to eliminate my x's. So I'm going to go with the 12 and -12. So if I multiply by 3 on the entire equation, I will get 12x plus 6y equals 24. Then on the second equation, I need negative 12 for my coefficient, so I need to multiply by negative 4 this time. Make sure that you're creating opposites. So one has to be positive and one negative after you multiply. So this one would give me negative 12x, negative 12y, and negative 36. Okay, now I have my opposites. I eliminate my x's. Add the rest of the system. Negative 6y equals negative 12. And divide by negative 6. So y equals positive 2. I'm going to go back to my second equation this time. And y is 2. So replace the y with 2. 3x plus 3 times 2 then equals 9. 3 times 2 is 6. And then we're looking for x. So I need to subtract that 6. 3x equals 3. Divide by the 3. So x equals 1. So these two lines intersect. They have one solution, and that solution is 1, 2. 1, 2. Okay, next one, 6 and 4. The LCM of 6 and 4 is 12. If you're not good at figuring out the LCM, you could always multiply them together. 6 times 4 is 24. That would work out just fine. You just end up with larger numbers. And then the LCM of 2 and 3 is 6. So either 12 and negative 12 or 6 and negative 6. I'm going to pick the smaller numbers. So I'm going to go with the 6's on this one. So my first one has the 2, so I need to multiply by 3 to make it 6. So I would get 18x plus 6y equals 6. Then the bottom one has a 3, so I need a negative 2. Because remember, you need one of them to be positive and the other to be negative. So now I get negative 8x, negative 6y, and negative 16. Add my system, cancel out the y's. Adding the rest gives me 10x equals negative 10, and dividing by 10, x equals negative 1. So x is negative 1. I'm going to use my top equation. You can use either one of the original equations or the new equations. Really doesn't matter. You've got 4 choices on this one. So x is negative 1. There's a 6 in front of it. Plus 2y equals 2. So 6 times negative 1 is negative 6. And then I'm trying to solve for y this time. So I need to add 6 to cancel it. So 2y equals 8. And then divide by 2. So y equals 4. So these two lines intersect and have one solution. They cross at negative 1, 4. All right, last one. This one's a word problem. The cost of 2 groups going to an amusement park is shown in the table. Use the information to find the cost for each adult ticket and each child ticket. So each group is going to be an equation for us. I'm going to use A for adult and C for child, and we're looking for ticket price. So if there are 4 adults and 2 children, 4A plus 2C equals $184. Then 4 adults and 3 children, 4A plus 3C equals 200 would be my system. So each group gets its own equation. Each group gets its own equation. Now looking at these coefficients, you can choose if you want to eliminate the A's or the C's. I am going to just multiply the top equation by -1 because that will eliminate the a's. So I'll get -4a, -2c, and -184. My second equation doesn't have to change. If you choose to eliminate the c's instead, which is totally fine, you would want to turn them into 6's. So -2 plus 3 is just 1. So one child is $16. So I know this is $16. And now I can figure out, I'm going to use my top equation. If children are 16, I can solve this equation. So 4a plus 2 times 16 is 32 equals 184. Subtract the 32. 4a equals 152. And then if I divide by 4, 152 divided by 4, let's see, 152 divided by 4, 4 times 3 is 12, and then 4 times 8 is 32, so $38. So 38 for each adult ticket and 16 for each child. And that's our last example today.